Hi there. In this probably quite short but slightly different tutorial, I'm going to talk about how to use Blender to create a 3D video for upload specifically to YouTube. Obviously you can also upload it to whatever 3D headsets you've got, or even view it on a 2D screen using either glasses or anaglyph glasses, and I'll explain a little bit about all of this as we go. Funny thing is, in this 2D video demonstration or walkthrough, the video that I've created to demonstrate it is not going to look quite right, as you can see from the screen in front. So here is the video that I uploaded to YouTube. There'll be a link to this in the description below this video, and you can see it's essentially two scenes slightly compressed in the x-axis and loaded side by side. Now Blender can create this directly, and then with a little bit of manipulation this can be uploaded to somewhere like YouTube and displayed as a 3D video. I find that these files can be put directly. For example, I've got an Oculus Quest and I can put it directly onto the Oculus Quest without any additional manipulation, and the Quest will recognize the 3D video and be able to view it. But I'll talk a bit more about what I've learned in this, my first real 3D video, as we go along. So here it is in preview mode, and you can see by default, because I've got a 2D screen, it's gone into anaglyph mode. So that's where it uses two different colors, one to represent the right eye and one to represent the left eye. So that's red and green essentially. And you can see they're both displayed at the moment. I'm in preview mode, and this is all about Eevee, by the way. If this was in Cycles, some of the things would be slightly different. You can actually do slightly more with Cycles than you currently can with Eevee. But you can see we've got a sort of greenish box here, which is the left-hand camera, and then there's a reddish box that you can't quite see because it's sort of yellow at the moment. It's the selected box, and that's showing your left and right camera. Now I do have a left and right camera up here, but in actual fact I don't even need one of those cameras because of the settings I've used. You can do this with two cameras, or you can do it with just one camera. I started off with two and that worked quite well, but then later on I just switched to using just one camera and that worked fine. So I'm not going to get into how to create the scene itself. That's fairly straightforward. I'll just show you what that looks like. So we're out of 3D mode there, and essentially I've got a plane that I've added some distortion to. I've then got some higher frequency distortion to give the sort of surface features. There's some texture mapped onto it. I've got a single light, which is a sun lamp, and then I've got a box which has got a volumetric loaded onto it and also an animated texture, which gives this sort of misty effect down here. And then finally a particle fountain here that's being used to drive a smoke stroke fire simulation to create this sort of steam effect coming out of this little geyser or whatever it might be called. And there's my camera, you can see there. So I'm just going to create a really simple scene so that I can talk about some of the settings that you need for a 3D scene in Blender, and specifically in Eevee. So we'll go to a new scene. And to begin with, I'm just going to put a simple plane on the surface. We'll make that a little bigger. Switch to orthographic mode so we don't get confused. And now I'm just going to add a few shapes on there. Scale that down. So there's a cube, there's an icosphere, and we'll add a cylinder in there as well. And we'll give each one a slightly different material. So we'll make this one a nice blue one, and we'll give it a blue color in the viewport as well. We'll add a lamp, which will just make a simple sun lamp. And if we preview that, there's our basic scene. And I'm going to set the background just to black, just to bring that out of the equation. So currently we are in Cycles mode. So I'm going to switch now to Eevee, because this is really what this tutorial is about. There are a few differences and a few limitations in Eevee as far as 3D is concerned. So you can see, obviously, the default settings give us a slightly cruder render for everything, but we can start to improve a few things. So I'm going to just turn on screen space reflections, and you can see we get a bit of radiosity appearing on some of these objects. I'm going to go to soft shadows, and that sort of improves the look there. And obviously we can improve a few other things as we go. One of the things I found did help for my animation was to bake in direct lighting. And that just is more to do with where you want to record the reflections of things like that. there's not really a lot to do in this particular scene. So there's our basic scene set up, and now we need to play with the camera. So I've got a camera here, I'll just switch it on. And at the moment it's just a simple camera. So I'm going to look through the camera now by pressing 0 on the numpad. And that's what we're seeing at the moment. I'll raise it up slightly and then zoom it in. So right now that's not a 3D scene. Obviously it is 3D in terms of the fact that it's rendered, but it's projected onto a flat 2D image. So if we now go to this little printer icon, the output options, we can see there's a box called stereoscopy, which is obviously another word for 3D. So we'll click that and look at what happens. Immediately we get this anaglyph effect. So we get a green image and a red image, and in the middle they're overlaid. There are a number of things we need to be aware of with this. But obviously the advantage of the anaglyph is if you have some red-green glasses, you can put those on and immediately see what your 3D image is looking like. Now, by default, it does have the capability to have a left camera and a right camera, and it gives you an option here to indicate what the suffix should be. Part of the reason for that is because you may want to render this out to images, which of course is the recommended way to render animations in order to be able to make changes later on more easily. And what you will in that case want to do is potentially render two separate strings of images, an underscore L1 for example, a left hand image and a right hand image, and that's what that's allowing you to do. But if you wanted to name it something else, you can do that there. If you want to use two discrete cameras, you can switch to multi-view and create two cameras. But what you'll need to do is to name them, in this case, underscore L and underscore R, so that there is a left camera and a right camera. That allows you to play around with very simply with the distance between the cameras and so on, and maybe do some other special effects as well. It's how I started out and it worked quite well, but I then found that using the simple stereo 3D option was much easier to do. You only need one real camera. Effectively, more cameras are created from that. Now you'll notice when it's in this 3D camera mode, there's actually a little plane appearing in front of it. That plane is the convergence plane. My rough understanding of that is that that's the point at which the two eyes are focused. So it's not actually to do with focus, but it's to do with where the eyes are pointing at. And essentially anything behind that plane, if you imagine the screen within here as a window through which you're looking, everything behind the convergence plane is outside, behind the window. If you bring anything closer than that convergence plane or push the convergence plane back, then they will appear in 3D terms to be in front of the window. Now, while you might want to do that occasionally, certainly for a windowed effect, you generally won't want to. You'll want it behind the window. So when I say a window, I mean literally a window through which you are looking. You're still seeing 3D. Both of your eyes are each getting a slightly different view, because 3D is all about that difference of parallax between the left eye and the right eye. But you can tell that everything is further away than that window pane through which you are looking. Whereas things that are closer than this convergence plane will appear to be in front of it. One of the problems with that is that they may very well coincide with the edge of the window. So if they're behind the window, that's not a problem. They'll be occluded, you won't see them. They'll be occluded in front of the window as well, because it also describes the edge of the image. But of course, something that was in front of a window, you would expect to see it. So you may get some slightly odd effects of things that are bigger than the window but appear to be in front of the window. I haven't done a lot of experimentation with that, but certainly I had a few issues with particularly the intro that I attached to my video and getting the convergence plane to work there properly. If they're staying within the confines of the window, I don't think that's an issue. So how do we adjust the settings for our 3D scene? So a lot of them are within the camera settings. So you need to have your camera selected and then go here and click on that little camera icon. It's a camera from about 1950, I think. That's why it looks the way it does. So nevertheless, that is the camera symbol. So you can see you've got a couple of options here. Now there is a panoramic one visible there, but it actually won't make any difference. There is no panoramic camera, unfortunately, available within Eevee at the moment. If I switch to cycles, you can see we've got a very different view. I'm not sure why it's jiggling about, but nevertheless, you can see that is a panoramic view. The whole scene, apart from the very top and the very bottom, is visible. In fact, probably the whole scene probably is visible. As I say, I'm not sure why that's jiggling around with each render, but nevertheless, That's what a panoramic camera does. It compresses things that are at the edge of our field of view, such that that point there is the same pretty much, or is right next to that point there. So if there's something, this point here is actually behind the camera. So that's looked at the whole sphere and wrapped it around and reprojected it such that, and distorted it so that it appears on this flat plane. That's how you get a 360 video. If you want to do a 360 currently, whether it's 3D or otherwise, you'll need to do that in Cycles, and Cycles obviously has its limitations. So I decided to do it in EV because one of the other considerations of a 3D video is resolution. Now obviously that's a consideration anyway, but because you're rendering 2 eyes worth, you're effectively creating 2 separate scenes from a slightly different perspective. You're having to render twice as much, and then you're having to display twice as much. Now I only did 1920 by 1080 image, so that's the sort of resolution I would typically do for a standard HD video on YouTube, but remembering that that's got both eyes embedded in that 1920 by 1080 image. So in actual fact, on the x-axis at least, that was half of that resolution. So although it was 1080 high, it was only 960 wide, so a lower resolution. So really, if you want to maintain that HD quality, 1920 by 1080, you'll actually need it to be 3840 by 1080, and that will then give you the same resolution per eye. Now not all 3D headsets are going to be able to display that, so it's up to you whether you want to render at that resolution, but certainly I could see that it wasn't the highest resolution 3D, and I'm sure you've noticed that it's not the highest resolution 3D video, even if you have watched it through a headset or with anaglyph glasses. In case you didn't realise, by the way, yes, if you looked at that video as it was created on a 2D screen, you'll have seen the default YouTube setting of an anaglyph video, so you'll have seen red-green. But actually, if you view that through a VR headset, it will have presented an alternative version of it, which will have been the side-by-side video version, which your headset hopefully will have recognized and displayed as a proper 3D image. So that's quite clever of YouTube in that respect. So we're in EV and we select our camera and we go to our camera settings. Panoramic, as I said, in EV doesn't work. I haven't tried orthographic, but it looks like that works. And the normal default is your perspective camera. Focal length, that's up to you. I generally leave that in default. Up to you whether you want to use depth of field, but things like that can get a little bit more complicated when you're dealing in 3D. I didn't bother changing any of the settings for the camera. The area of real interest is the stereoscopy options. So I didn't bother changing the default here. This is to do with how the virtual eyes are working. But here is our convergence plane distance. So if I look from the side here again and play around with that convergence plane, you can see I can move it in and out. So if I put it here, all of these objects would appear to be in front of that window through which we are looking. Obviously, if I bring it right up to the camera, everything is going to appear to be behind the camera. But I think somewhere around there is a reasonable distance. This one, it's worth leaving at default. I measured my own eyes, and they're somewhere in this range of about 6.5 centimeters. It's not going to completely break the 3D experience if you select a different interocular distance. I think what it does is rather similar to focal length. It's rather similar to if you use a very tight depth of field. So if you have a very tight depth of field such that only things right at the focal point of a camera are in focus, it gives you the impression in a scene that the scene is very small, as if you're looking almost through a microscope. If you have a very long depth of field, things appear to be much bigger. So if you had a scene with a load of houses in it, you would expect to have quite a good depth of field. So everything near the camera would be in focus typically, and everything far away would be in focus. If on the other hand, perhaps in that same scene, there was a hand holding a Lego brick or something, and the camera was focused on that Lego brick and the houses were somewhat blurry, that would give you the impression that that Lego brick and that hand were obviously a lot smaller than the houses. And sometimes when people play around with 3D and their scenes, they'll often create something which they're presenting as a large thing, but then they have a depth of field which is too tight, and it sort of breaks the illusion and makes you think, well, actually this is little tiny models because it's got a very tight depth of field. Obviously it can be used for artistic reasons as well, and then all bets are off. So I think interocular distance has a similar effect, but in 3D. So if you imagine relative to an object, if that object is much, much smaller than the distance between your eyes, then it must be a small object because the distance between your eyes is only 6.5 centimeters or thereabouts. If, on the other hand, it's many, many times bigger than that interocular distance, then it must be an object which is a lot bigger than your head, for example. So what I'm trying to say is that by having a larger interocular distance, I'm learning about this as we go, that this will give you an impression that the objects you are viewing are smaller. The bigger you make this, the smaller they will appear to be. That said, if you want realism, you probably need an interocular distance that is appropriate to the scene you've created. So if you've created a scene and you've stuck religiously to a unit of measure, so the scene is in meters and you're representing a room, then you need an interocular distance that is representative of a real interocular distance. So depending on the size of your head and the spacing of your eyes, they're probably going to be somewhere between 5.5 and 7.5 millimeters, 7.5 centimeters, something like that. Millimeters would probably be a fly. And you can obviously also add in playing around with focal lengths as well, and the combination of the two should give you a more visceral impression of size and distance and parallax. So this bottom one, I think, is just when you rotate the camera, are you rotating around the midpoint between the two cameras, the right camera or the left camera? I just left it on the default of left. It didn't matter too much for my scene. So once you're happy with that, you can go into your scene, and by default it will be in anaglyph mode. Now if you're going to upload to YouTube, I played around with a number of options and I found one was much easier to work with than the other. So you're going to render it out to however you are going to render it. I actually rendered straight to video, which I don't recommend, but it was a relatively short video, and one of the great things about Eevee is that you have quite short render times, and so you can take risks, as it were, by rendering straight to video rather than rendering individual frames, which is the way I would normally do it. So I just rendered to an AVI JPEG. But then we've got a couple of options here. So individual, it will render separate files for the left and the right. But we can say stereo, and this is what I did. So I didn't want to get into recompiling it to create the video that I then uploaded to YouTube. I wanted it to be in the minimum number of steps. And then we get to choose what modes we're going to do. So we've got anaglyph, which is of course the default display that we've got up there. We've got top, bottom, side by side and interlaced. Now I didn't do anything with interlaced. I suspect that's mostly for 3D monitors. What I did was I first of all started off with top, bottom. The advantage of top, bottom is you are compressing the video on the vertical axis, but you are not compressing it on the horizontal axis, which is of course the widest axis. So if I render just one frame, it shouldn't take very long, and there it is. So I've rendered one frame there, and what I want to do is also click this squeezed frame. So it won't actually show it on the screen, it's showing a combined image, but rather than an anaglyph like that, what it will actually create when I output it to the disk is two images. If it's set to side by side, it'll be one image on the left and one on the right. If it's set to top bottom, it will be one long image at the top and another one at the bottom. As I say, top bottom is typically better, but I spent quite a bit of time trying to get YouTube to accept a top bottom video. I had no problem uploading that video straight to my headset, my Quest, and that recognized it straight away. But unfortunately, I couldn't get that to work after uploading to YouTube. So I ended up switching to side by side. As I say, the preview when you just render to the screen like this for a single image will look like anaglyph, but when it outputs it to a file, it will actually be a file, if you do this, with both images in it side by side. If you want to turn the anaglyph off, by the way, on that rendered image, you can just click this little button here and it will just go back to one of the views. Now that's the left view and there's the right view. You can see slight differences between them, and that's the combined view. So once you've done that, you'll get a video something like this. So this one has got my intro in it as well. There's no sound on this video, obviously. And then it's going to roll into the main animation. And you can see there it is side by side. If we move into the animation, and you can see how that works. So it's been squeezed on the x-axis in order to fit both images in. They're 960 or so wide. But unfortunately, although for me at least, putting that onto my headset and viewing it worked fine, you can't just upload that to YouTube and hope for the best. At one point there, YouTube had an option to set some settings after uploading a video to tell YouTube what kind of 3D it was, side by side, top, bottom, and the fact that it was 3D. Unfortunately, they took that away. So what you now need to do is to add something called metadata to the video. So essentially, this is some settings in the header information of the video file to tell YouTube what kind of video it is, that it's a 3D video, what mode of compression it had. Now, I composited my video after use and I created an H.264 video, which is the mode that I normally upload in. So that's an MP4 video essentially. And I have here a record of what I use to add this data. Now, I used a little utility called FFmpeg. If you just do a search for FFmpeg metadata, you'll soon find it. It's a freeware piece of code, and there are a few others available as well. It's a little bit clunky because you have to run it from a command prompt and then give it some instructions. So I created a little link to my command prompt in the folder that I've got the videos. So I just run that and you can see it appears up here. And then just copy this, and I'll explain a little bit more about these commands in a moment, and paste them into here. So what I've got here, I'll show it on this one as it's a little bigger. This is just the program that I'm running. You can see I downloaded it and there's a copy of the program there. These folders are folders that come with the program, and they just contain some library information that it needs. We need this -i, and then we have the file name of the file that contains our video that we need to add some metadata to. We then tell it what kind of encoding it is. I think it will probably work even if you don't include that, but this was the default command. If you look on the YouTube help site and look for 3D videos, they actually give you this command, and they'll also give you a link to the tool as well. The important one is this, and again I think this whole command string is available on the YouTube help site, and this basically tells it that it's a side-by-side video. Equals 4 is a top-bottom video, but like I said, even though I tried it with that, YouTube just never seemed to recognize it. Just 3D just didn't work using that, at least with my videos. Maybe I was doing something wrong, but I did spend quite a bit of time trying to research it. So that tells the program what kind of video it is. So it's telling it it's a side-by-side video. And then you just need a name for what you want, how you want it to output it. So I just added the words meta on the end of it. So you run that, and I'll just run this one up here and you can see what happens. And it's going to just run through, and it does some analysis of the video first of all. And then it takes a little while because my video is about 0.5 gig in size and does a lot of processing. You can see it's going through the frames there, and I think it was about 3,000 frames, something like that. So it takes a little while and it then creates the file. I'm just going to ignore that. Once it's created the file, if you do use the command I did, it will actually compress the file as well. And we're not too worried about that, but you can see I've now gone from an uncompressed 0.5 gig file to a compressed 60 meg file. So that's quite good. But if we look at it, it's pretty good compression. You don't really see any difference. So it's the sort of compression I think that YouTube does anyway. So you're not really losing a huge amount. There is an option, I think it's -copy, where it won't do any compression. It will just simply add the metadata to the file and then make a copy of it with that metadata on. But it's quite handy to upload to YouTube, especially if you don't have the fastest of internet connections, the way I don't, to have it as a compressed file. As you see, there's no actual difference that you can see in the file other than it being a lot smaller, but it has this metadata in it. And then when you upload it, YouTube will recognize that it's a 3D video, and by default on a 2D monitor it will display it as anaglyph. But when you look at it through a headset, and particularly if you use the YouTube app, you will get a 3D video. So that's really all there is to the basics of creating a 3D video for upload to YouTube in Blender. I'm hoping that in the not too distant future we will get the opportunity to have a working panoramic camera, because once you have that, you can create full 360 videos in 3D and using a render engine which doesn't take very long at all to produce reasonable results. I am thinking about a way that we could create panoramic effects using EV. Whether they'd be faster than Cycles is another matter, because effectively it would be using multiple cameras, probably at least 6 cameras, possibly more, but there's quite a bit of maths needed for that because you need to distort the images and so on. And another thing I'm considering is whether or not you could do it using reflective spheres and essentially just record the images from as they're seen on reflective spheres. And again, there's a mapping exercise to do to turn that into a proper 2D image. There's some things I'm looking into there, and maybe I'll be able to come up with a method for producing 360 and 3D videos in Blender using the Eevee engine. But hopefully, in the not too distant future, we'll have a proper panoramic camera available in Eevee. So I hope you enjoyed that. If you did, let me know, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well. And I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.